So I'm Sean. I am the creator of pion-WebRTC. And if I have one goal for this talk, I want you to feel like the same excitement and enthusiasm that I did digging through all of these things. WebRTC in itself, like once you see how all of these crazy unrelated things came together to make something that we can communicate in sub-zero time, the fact that people say, oh, live video is 15 seconds, like that's not acceptable for a lot of these use cases. Like most people are saying like 200 milliseconds is the maximum that I can do. And it's amazing that people came together and made this. They pieced together all these parts that are completely unrelated and made something really, really interesting.
Hey Sean, what does WebRTC do?
Oh yeah, yeah. So just to move on, WebRTC, if you just get the generic description, it starts off with real-time communication between browsers and mobile. Really generic, doesn't tell you that much. And that's sort of what it always started off for. For me, when I started working with this, it was like 2015. WebRTC was already pretty big. People were building stuff with it. But I had no background in it. And I thought, oh, build some simple conferencing apps, allowing me to talk from one person to another. And that's it. But as I've gotten involved in this project, RTC, it just amazes me, all of the interesting things that come out of this. One that's caught my attention recently is Tor's Snowflake. So like censorship circumvention. So the idea that my browser can talk directly to your browser. So if I can't access a website, but you can, I'll download that website for you. So imagine like this beautiful snowflake and all these nodes communicating with each other. So now that we're not dependent on communicating directly with servers, let's communicate with each other. Server-side processing. So this is one that's really, really exciting. Now that you see everyone's coming out with interesting things, like I want to know what was said in this video, or I want to know what images are on the screen. Like now we can do that in sub-second time. And the other really cool one is starting to see this augmented reality. If anyone was at Cranky Geek, someone got up and showed off the HoloLens, and it's amazing the things we can build with this. So let's just go, this big name. So here's a nice simple graph of all of the random technologies we decided to slap into a box and have fun with it. So you'll recognize some random acronyms in here. So all of these come together. How do we solve the problem that me and you want to communicate in sub-second time, not in the same network? So you're on one NAT on the other side of the world, and I'm on the other NAT on the other side of the world. So can't talk to each other directly. We can't trust each other. So anyone who's listening in the middle of us could be eavesdropping. So we have to make sure it's secure. And it has to be sub-second, and we have to accommodate for either lossy communication or perfect communication. So sometimes I want to send you a message that has to be perfect. Sometimes I want to send you a message that I don't care what order it comes in. Think like, Quake 3 gaming. Like you only care about what's most recent. So the first part is like, how do we speak WebRTC? Anyone's worked with, we have SCTP, so the session description protocol. And the simplest part is like declare properties about yourself. So these are the video codecs I support. This is my IP. These are the video tracks I'm going to send you. So WebRTC supports, I can send you an arbitrary number of video streams. I can send you an arbitrary number of data streams. So this is, if you've ever used it in the browser, all of the add media track and stuff like that, all that's really doing is munching together this key value text format. And that's all that really matters, browser to browser, and then browser to mobile. So now here's where the fun part starts. All the communication is over UDP. And the first thing you think is, this is about to be awful. I'm going to lose messages. I can't trust anything. But that is where the fun stuff and why it becomes really important. So the first problem is, how do I talk to you? You have a IP that I can't directly access, and I have no idea where you are. And I remember when the first time I realized how this worked, I just thought it was absolute black magic. It was so exciting. So you'll hear of stun servers. So the idea, if I send a UDP packet to a stun server on port 5000, and it communicates back to me on port 5000, I've punched a permanent hole. So for the next 30 minutes, if someone sends a packet to NAT B on port 5000, it's passed through to my browser. So now I can send, if you've punched a hole on port 5000, anyone can send a UDP packet to you, and it gets passed through on the inside. And the first time I realized that, I'm like, this is absolute magic to me. I'm amazed that someone figured out all this and how it all works. So now we solve the problem is how do we communicate? I know your public IP and I know the hole that I've punched. So now we can start talking to each other directly. So we can pass messages back and forth to us. Wonderful. Where do we go from here? The next problem is how do we communicate with people listening in the middle? So we had to implement DTLS, which is just TLS over UDP. So all of that normal TLS handshake, but you have to account for loss. The part that excited me most was when I grabbed a textbook and I figured out Diffie-Hellman. And there's an example on the next page. It just is amazing, the idea that me and you can both pick private numbers and communicate over public internet, and no one can steal those private numbers, which is like a fantastic mathematical thing that I'm amazed someone figured out. But the idea with TLS is let's just generate a bunch of shared state. I'll send you some private random data. You send me some private random data. Let's pick a cipher suite, AES, GCM, something like that. And I don't know, it doesn't really matter to talk through the details, but the idea that with public-private key encryption, and the idea that I can send you something, and even if someone is eavesdropping, they can't steal anything from us, is just one of the parts of the magic that makes this all happen. Okay, so now we're able to send messages to each other, and we're able to do it in an encrypted fashion. So now we have all these packets. The next problem is, so everyone here is probably familiar with, H.264. So we can start sending video buffers to each other. Well, the problem is that it's over UDP, so I'm losing 3% of them, which is awful. Everything's pixelated, it just randomly dies. We can't have that. One of the really cool parts of WebRTC is the jitter buffer, or the ability to account for loss. So me and you start a video session, and I send you 100 packets, you send me 100 packets. I can adjust the amount of delay dynamically. So we start off and I lose maybe 3% of your packets. So I say, okay, I'll wait an extra 10 seconds to wait for more packets. And it'll actually rubber band to wait as the amount of time that it requires for all those packets to arrive. And if all your packets are arriving on time, it'll lower that latency. If some of them are behind, it will raise that latency. So I'll say, okay, I have to wait 50 milliseconds. And in those 50 milliseconds, I can then use RTCP, which is just a message format that I send to you, and I say, hey, I lost packet 312. Please resend it. And if you can send it back to me within that latency, we end up with a perfect picture. So in sub-second time, you can send me 99% of your video packets. Before those 100 milliseconds elapse, can send a message back and say, hey, crap, we're almost there. Give me the last couple ones. And there's some of the magic behind this. So now me and you are communicating over a lossy connection, and we're able to accommodate lost video packets. And all of the encryption for this is we already got via DTLS. The nice thing is that DTLS handles all of the getting those encryption keys, and then SRTP was something that's existed for a long time. So the next part is SCTP. So SCTP is sort of analogous with that. I want to communicate and send binary messages back and forth. How do I send them back and forth and either allow for loss or to be lossy? There's some cases where you're okay, you just want the most recent message. So think like net gaming. Like you don't care what happened 600 frames ago. You want to know what happened right now. And if you wait for 600 frames ago, you're falling behind. So SCTP allows you to say, I'm going to negotiate a channel with you. Now that we've negotiated a channel, what do we want to do with it? Do we want it to be lossy? Do we want to just throw everything away? And we can negotiate multiple streams. It's sort of the whatever you want to send fast protocol. SCTP has a lot of cool history behind it. If you look, at where it came from, it's like all this telecom stuff, and then they tried to make it happen. And so it seems like most people have just stolen the SCTP implementation from FreeBSD, and now it's just sort of floating around. So it's very a weird protocol, and so people will run it over UDP, but it's not even meant, the original intention was to be sort of this better solution, but it didn't really catch on. So, and apparently it doesn't even end there, so we have this whole hodgepodge of protocols and people want to add even more, so we'll see what happens. It's ever changing. The original version of WebRTC didn't even have SCTP, so that was added after the fact. So it feels like it's an ever-changing thing. Okay. So the reason why I'm interested in this is I created a project called pion-WebRTC. And one of the issues that I ran into with the current implementation of WebRTC is it was designed with conferencing and all of these like existing applications in mind. Like it doesn't give you access to send arbitrary video easily. It doesn't give you access to bring your own encoder. So you'll see a lot of people on the mailing list who are asking, how do I do this? And they're frustrated or confused. And so instead, pion-WebRTC has 0 assumptions. However you want to use it, use it. Like you can pass in whatever video you want. If you want to respond to events, you do it how you want. Also, all of the pieces are built by us. So we rewrote OpenSSL, SCTP, SRTP, ICE in Go. So it's been like an 8-month ordeal. But now that we have all of this, it allows us to do really interesting things, which you can talk about later. And then the best part is now we have all these cool pieces, and I'm trying to push them into other repositories like XNet so that everyone can use DTLS. So now that everything's really easy to use, if anyone has built libWebRTC, it's like a week-long process. You have to know how to use gclient sync and have fun. From my Mac, this is the only command I need to run to build something for Linux. So that builds everything. I now have full data channels, video encoding and everything. So I use that to process video on a back end and do interesting things. That's the extent of my build. Community owned. So it's all on GitHub. There's no, don't have to go off to a third-party system. I don't care where you're from. In the 8 months we've been around, we have 16 contributors and about 5 to 6 active ones, and it's a fantastic little community. It's like very exciting to see other people just talking away without me even involved. I can walk away for 3 days and people are merging PRs and doing whatever they want. All you need is one sign-off from another developer. So there's no like benevolent dictator for life. It's like, let's build this beautiful little playground and see what happens. And then 100% free software. There's no binary blobs. I know Tor projects have an issue with this right now, is like Google Play is required to use libWebRTC on Android. So what has been built with pion-WebRTC? This is a cool little project, Webb TTY. So I can be on the other side of the world and I can drop a little binary and share my terminal, and then anyone in their web browser can open it up and then see what I'm typing and then type into my browser as well. There's no man in the middle. There's no relaying through a central point. We're sharing without anyone in between. So I think it would be really cool. So a lot of like small IT companies will have like jump boxes or something. You'll SSH into one and then you'll SSH into your network if you don't have a VPN yet. Like this could be a great alternative. Now you don't have to open up your internal network. You can fire off this one temporary binary, have a secure session where you share your terminal and then move on. The other interesting one is RTC tunnel. So if anyone's used NGROK, you have this local HTTP server that you want to share with the internet, and you have someone that you want to collaborate with. Now that you can just share like port 8000 with anyone in the world, you just ship that data over SCTP, and now anyone can access it. So instead of depending on some central service and having to send all your data through them out to the internet and come back, now it just goes directly between me and you, and it's encrypted. We're starting to see some non-public video users. I have a company in Australia and a startup in, I think it's England. Very cool, like these weird little things. I don't know if they feel comfortable with me talking about, but I love seeing all these people come up with these unique ideas that they're just slowly building. And the one that excited me, now that we're Go native, someone's putting it on an Android security camera. So it's just so cool to see with one command they build this binary, and it's all these going in these weird places. So here's what I want to see in the future. With Go, you can build C bindings. And so eventually we'll be able to just have one Go build. I can throw you an SO with some header files, and all of a sudden, like this portability, and you're not limited to just using Go. There's nothing easier to target than C. File sharing. So the way I see this is I love to share files between me and you, but don't want to use a man in the middle. And then on top of that, let's say you rent your own server, and you can share and sync files between you and that server without having to depend on anyone else. I could see that would be a great little use case someone could build. The other one is an auto-scaling or peering SFU. If you've ever tried to build your own conferencing app, you drop one install of any of those popular open source, Jitsi, MediaSoup, Janus, and the scaling issues sometimes come up, and everyone solves them differently. I'm hoping to get to the point where I can just throw Kubernetes and have them peer with each other. So if you reach a certain capacity, you can just start sending off video to another node, and that can host it as well. Who knows when I'll get time? Like I'm barely head above water with this project. And really insert your application here. The thing that excites me most, that motivates me most about this project is the things that other people are building. Like that's what makes it so fun. So anyone who wants to join the public Slack or anywhere that you want to communicate, I'd love to just build those interesting ideas that you haven't been empowered to build with other tools. So nice little short talk. So any questions, and then also correct my mistakes. Everything that I figured out was just through reverse engineering. Pion is just an open source collective of just a couple developers. No companies or funding of any sort. It's just me. And so everything that we figured out was sort of just like digging through other people's code bases, printf debugging, OpenSSL, just every miserable thing you can imagine we had to do once. And so we've got to this point. Yeah.
That's awesome. Thank you so much, John. Anyone got questions? Got a question?
At the very beginning, you talked about name value pairs and exchanging them. Say, oh, this is what I'm gonna. Here's what codex I support or whatever. How are those name value pairs defined? Where is there a central repository of them, or it gets updated? How does it evolve?
Yeah. So there is like a spec as far as WebRTC, but it's incredibly fluid, and every browser sort of acts differently. So at one point, there was one way for me to declare the name of the video stream that you're sending. I think there's 4 different ways to declare it now. And everyone just sort of, so I send all 4 types, and if you're Firefox or Chrome, it works.
It just seems like there'd be a way to point to a namespace. Here's my namespace. And then you can, do you understand this namespace? And this namespace can evolve, have versioning, and so on. It seems like because it's web friendly and it's
So SCTP is standardized. Every web browser and every implementation of WebRTC parses and emits the SCTP. As far as all the key values, I think that they're pretty much agreed upon.
Okay.
But I can't point you to a single RFC for them.
Yeah. And the other question was, why Pion?
Oh, so Pion is like a small building block for an organism, so like a nucleus, a pion. Okay. So the idea was eventually when I get time, I want to build other interesting building blocks to like empower media applications. So like the other one is I eventually want to get around to like maybe moving like video decoding and encoding in Go, like maybe just write the hard stuff in assembler, but all of the easy stuff like passing buffers around in Go. So I think it's a wonderful language for building server software, especially the fact that I can build static binaries and send them anywhere. Yeah.
Any other questions?
RTCP, SCTP establishes the qualifications of the connection. MPEG, SAND, and DANE do that. Why not use their syntax?
So for the STP, it's simple text value based. Like it's really, I don't want to say lowest common denominator, but it works, and it works very, very well. I can't testify to why they chose it. I'm not a spec author at all.
So it's there.
Yeah, it's there and it works. But I can say it works. It works really, really well, and it's pretty easy to use. So I would defend it with that.
Did you cover turned?
Yes, I wrote. We have a turn server that we wrote. So to give the quick on that, so with stun, instead with turn, a turn server, B would establish a session with the turn server, and then you would send your packets through that turn server. Okay. Yeah.
So Yuri has a quick response to.
And at some point, ISO-AC defined the entire network stack. It was a wonderful effort on this ISO network hierarchical system, and if things would be going ISO way, internet would have been a lot different. But thankfully, it's not.
One quick question about Webb TTY. Is that sending the actual terminal image to the other person as images or video, or is it only sending text data over the data channel?
I believe only text data over the data channel.
Awesome.
Yeah. So, but there's no reason that you couldn't encode and send,
Sure.
a frame.
But it's probably more efficient not to.
Yeah. So yeah, just data channels. But I actually had I would say nothing to do with Webb TTY. It was one of those projects that just showed up. Someone said, "Hey, I built this really, really cool thing." I'm like, I wish I could have built that, but I have none of those polished skills that require building like an end user product like that.
That one sounded neat to me.
Yeah. No, it's very cool, and the RTC tunnel is just amazing as well. I'm very excited to see just like these ad hoc VPNs.
Awesome. Thanks again. Thank you so much.